Hey Trig class, we're going to be looking at section 5.3 and 5.4 in this lesson. They all have to do with identities called the sum and difference identities. So let's go ahead and take a look at those. Okay, so what is being shown here, these are some new identities. They are the sum or difference identities for sine, cosine, and tangent. It's just when we are adding two angles together, um, we have these identities where we can find the exact values of our cosine, sine, and tangent functions whenever we are adding two or subtracting two angles together. So you'll see that in the next example that I have for you. We're going to put all of these identities into use. Okay, so let's go ahead and do that. So before we get into using those new identities, I want to tell you we're going to be, like I said before, we're going to be using those identities to find exact values of expressions. Previously, we have found exact values that dealt with angles that had something to do with 30, 45, or 60-degree angles, or their coterminal angles that equal those amounts, or their reference angles that equal 30, 45, or 60 degrees. Okay, so here we're going to be using those three angles again, but we're going to be adding them or subtracting them together in order to use them in our sum or difference identities. So let's look at this one right here. Cosine of negative 75. Well, I'm going to show you it like this. If we split our angle into this, I'm going to say, let's split it into negative 30 degrees and negative 45 degrees. Negative 30 and negative 45 add up to be negative 75 degrees. So now here we have two angles that are being added together. Let me go to the previous page. And when we add angles together, this is the identity that we are going to follow. So I'm going to write that down on the next page. So we are using cosine of A times cosine B. And this is minus sine A sine B. Okay, so now this is the identity I've written. Your angle A is this negative 30, and your angle B is this negative 45. So plug it all in at this point. So cosine of negative 30, cosine of negative 45, minus sine of negative 30, and sine of negative 45. All of these are degrees. Okay, so now since we should know the angles or the values of all of these cosine and sine functions we have here with our angles, we can go ahead and replace the cosine of negative 30 with what it is equal to. And you can use your unit circle to help you in figuring out what each of these are equal to. So cosine of negative 30 is equal to cosine of positive 30. So is square root of 3 over 2. And then cosine of negative 45, that is equal to cosine of 45, which is the square root of 2 over 2. Then minus this stuff over here, so sine of negative 30, which is equal to the negative sine of 30. So negative 1/2. And then sine of negative 45, let's see, that's negative sine of 45. So you put in negative square root of 2 over 2. So if you don't remember where I'm getting these values from, please email me or ask me in class later. But just remember, all of those values can be found using your unit circle, like we have done in the past. Okay, now at this point, we are going to combine everything together. So we get this multiplies to the square root of 3 times the square root of 2 multiplies to the square root of 6. And then 2 times 2, that's 4. And then minus, let's see, 1 times the square root of 2, that's square root of 2. And both of these are negative, so it's going to become a positive whenever we multiply them together. And that's over 4. So putting this all together, well, these have the same denominator, so write your numerator, which is square root of 6 minus square root 2 all over 4. And that there is the exact answer I am looking for. So we're done on that one. All right, so let's take a look at this next one. What this next example is going to do is we're going to be using the sum or difference identities from the previous slide that I had here, but we're going to be working with it using the right side of our identity and going back to the left side of our identity. So looking at this right here, we have cosine of 73, times cosine of 83 plus then a sine value and another sine value. Okay, so match it back to one of these identities here. And what we have is 2 cosines being added to 2 sine values. Okay, so we're using the cosine difference identity. So what we're going to do is we have our A and our B, going to plug it in this way here, and then subtract the two. So we get this is equal to cosine of 173 degrees minus 83 degrees. And when we subtract the two of those, we get cosine of 90 degrees. And then we know should know the value of cosine of 90. That is equal to 0. And at that point, we are done with this one. So that's how you would use those sum or difference identities, but backwards. All right, in this example, sine of negative 15 degrees, we're going to do the same thing we did with the cosine of negative 75 degrees. Okay, so I'm going to split this angle into something that we know that adds or subtracts to negative 15 degrees. Two angles that we have used before and we know exact values of are 30 degrees and 45 degrees. So I'm going to say sine of negative 30 degrees minus 45 degrees. And now let's use the sine difference identity here. So this sign right here just means make sure you follow the difference identity and not the sum identity. So this is how it's going to break apart. We're going to say sine of our first angle times cosine of our second angle, which is 45 degrees. This negative does not go along with it. It's just part of the difference identity. Okay, and then minus cosine of our first angle times the sine of our second angle, 45. Now we know all of the values for each of these, so write those in. So sine of, positive 30 degrees, not negative. I was about to say negative, is 1/2. So 1/2. And then cosine of 45, that's the square root of 2 over 2. minus, and cosine of 30 degrees, it's the square root of 3 over 2. Oops, not 2, 3 over 2. And times sine of 45, which is the square root of 2 over 2. Okay, now just like the previous one that we did, like this, add or multiply these values and then multiply these values and then subtract them together. So we get square root of 2 over 4 minus the square root of 6 over 4. Again, these have common denominators, so no need of finding a common denominator. Just put everything over 4. So it's going to be square root 2 minus square root 6, and we are done. Now on this one, the one that deals with radian measurements, what I would suggest everyone to do is actually convert your radian measurement to a degree measurement. I think degree measurements are a little bit easier to deal with because they're not fractions for one thing. So that's what I'm going to do in this case is change this radian measurement to a degree measurement that's easier to deal with. Now this one does have a few more steps to it than the previous ones that we've done, but let's go ahead and work with it. So turning this radian measurement to a degree measurement, it would be 195 degrees. Now, 30 and 45 degrees and 60 degrees, the angle measurements that we know that we have exact values for, none of those will actually, no two of those angles will add up to 195. So in this case, what I would tell you to do is find the reference angle to angle measurement 195. Okay, and when you do that, that is in the third quadrant, so its reference angle would be 15 degrees because you're going to be subtracting 180 degrees from it. And tangent is positive in that third quadrant, so we're just going to find the tangent of 15 degrees. Now 15 degrees, anytime you're dealing with tangent in these sum and difference identities, I would say let's use values of 60 degrees and 45 degrees, just because those two values are not fractions. Like tangent of 30 degrees is the square root of 3 over 3. And when you put that into, put that into something that is already a fraction, you're going to have a complicated or a complex fraction to deal with that you have to simplify. So let's use, in this problem here, 60 degrees and 45 degrees to come up with your angle 15. So I'm going to say tangent of 60 minus 45. These are just some suggestions. You don't have to follow it this way, but I would. All right, so let's follow the difference identity for tangent, and what you end up with is tangent of 60 minus tangent of 45. And that's all over 1 plus tangent of 60 times tangent of 45. Now plug in the values that you know these are all equal to. So tangent of 60 degrees, that is the square root of 3. And then tangent of 45, that's 1. And then you got 1 plus, now tangent of 60, that's the square root of 3. Tangent of 45, 1. So same values up here that you're going to use down in the denominator. So this is just square root 3 times 1, which is just the square root of 3. And there you go. That is as simplified as your answer is going to get here. So if there are no fractions within the numerator denominator, you can stop right here because it is not a complex fraction. This is what you want here. And that's it for the sum and angle difference identities. Now I do have one more of these examples for you that deal with these new identities that we're looking at. And again, we're going to be using our tangent sum or difference identities, but working from the right side and going back to the left side. So this right here, this looks a lot like our difference identity for tangent. So you're going to be subtracting our two angles. And this is, let's call this our angle A. And this here, let's call it our angle B. And for our difference identity for tangent, I'm going to say 100 degrees minus 70 degrees, which is equal to tangent of 30 degrees. And we know tangent of 30 degrees is the square root of 3 over 3. And we are done. All right, so in this section, or two sections, we come back to our cofunction identities that we have looked at before. And but with our sum or difference identities that we have learned, we can actually see that if we use them, we can simplify this function right here down to a single function of just sine of theta. Okay, and all of these others, we can use those difference identities in the same way and end up with one single function, trig function. Okay, so here I have, it says if either angle A or B in the identities for any trig function where you're adding or subtracting two angles, if either of those angles are one of your quadrantal angles, so angles like 90, like your cofunction identities, or 180, 270, 360, or any of the coterminal angles of one of those angles, then the identity allows us to write the expression in terms of a single function of A or B, rather than A and B together being added or subtracted. Okay, so here I'm going to show you some examples that deal with the quadrantal angles that we have. In this example, we are asked to write each function as a trigonometric function of theta alone. So what that means is write it as a single function. Okay, and here what we're going to do is we're going to use our sum identity for cosine, and that is going to split this up into cosine of 90 degrees times cosine of theta, and then plus sine of 90 degrees times sine of theta. Okay, now after we've split it up, the value for cosine of 90, well, that's 0. So we have 0 times cosine theta, and then the value for sine of 90 degrees, that's 1. So we have 1 times sine of theta. Well, do the math here. 0 times cosine, that's 0. 1 times sine, that's just sine. So this is all equal to sine of theta. And there's our answer. So let's do this again with sine and tangent. Each of these are quadrantal angles, or they are coterminal to a quadrantal angle, like pi over 3. Let's split this up with its difference identity. So sine is going to be split up like this right here. So cosine, no, that's sine. Sine of angle theta times cosine of 270 minus cosine of theta times sine of 270. Okay, so now sine of theta stays the same, but cosine of 270, well, that is equal to 0. So what we have is sine of theta times 0, and then cosine of theta times, and then right here, sine of 270, that is equal to -1. So we have 0 minus cosine theta times -1 turns that to positive. So we have cosine theta is what that is all equal to. Let's do this one more time, but with tangent. Excuse me. So using the sum identity for tangent, I'm going to split this up and say tangent of angle theta plus tangent of 3 pi. And that's all over 1 minus tangent of theta times tangent of 3 pi. Now plug in your values that you know these to be. So tangent of theta, and then tangent of 3 pi, that is 0. And then 1 minus tangent of theta times 0. Okay, so that's going to give you tangent over 1, that is equal to tangent of theta. And we are done with those. So that's how you're going to use your sum and difference identities to change something into just a single function of theta. All right, in this example, we are going to be using, again, the sum and difference identities for us to be able to find each of these. So sine of angle A minus B, cosine of angle A minus B, tangent A minus B. And then we're going to figure out from these solutions here what quadrant your angle A minus B is in. Okay, so how we're going to do this is first look at the information that we are given. We are given cosine of A is 7 over 25, and we're given what quadrant it is in. And then sine of your angle B is -3/5, and then what quadrant it is found in. That is actually supposed to be a B. Okay, and then from there, what we need to find after this is we need to find what sine of A is equal to and what cosine of B is equal to. So from this given information, we're going to find sine of A. And then from this given information, we need to find what sine, sorry, yeah, sine of cosine of B. Sorry, guys. Whoops. Cosine of B. All right. So we should know how to find, given one trig value, we should be able to find the other trig values for sine, cosine, tangent of whatever angle we're given. Okay, so let's find what sine of A is equal to first, and then we're going to look at finding all of these other solutions. Sine of angle A. Okay, I'm going to use the Pythagorean identity in a way I've really never shown y'all in class before, but I know that Pythagorean identity will work out like this. It is going to be the plus or minus of the square root of 1 minus cosine squared of angle A. Okay, that is the Pythagorean identity, just already solved out for sine of your angle. Okay, so now let's look at this. First, I'm going to start out with the sign, plus or minus. Well, since we are in quadrant, let's see, that would be 3. Your sign is going to be negative. So I know this is going to be negative square root of then 1 minus cosine squared A. Well, you have cosine A is this right here. So plug it in, 7 over 25, and square it. And now we're going to reduce that. And when we reduce that, we get square root of that number over this one. And that again reduces to negative 24 over 25. Now let's go ahead and find cosine of B. Again, I'm going to write that Pythagorean identity out in a different way that you've seen it before, but never actually used it in this manner. Get my angles confused. There. So now to find cosine of B, let's use this Pythagorean identity. And first, just like before, let's look at this right here. Let's figure out which one is it going to be. Is it going to be plus or minus according to what quadrant angle B is in? So we are in quadrant 4 in this case, and cosine is going to be positive in quadrant 4. So let's say positive of 1 minus our sine squared B, so negative 3 over 5 squared. Let's make that look negative. There we go. And then do the math here, simplify that, reduce that radical, and you end up with 4 over 5. Okay, so now to tell you, the reason we needed to find all of these is because we need them in our sum or difference identities to solve for the values for sine of A minus B, cosine of A minus B, and tangent of A minus B. Okay, so let's take a look at the next page now and figure these problems out. So sine of A minus B. I'm going to write out that difference identity. It's sine of A times cosine B minus cosine A times sine of B. Now we have all 4 values because that's what we solved for on the previous page. We were given 2, but then we had to find the other 2. And after finding the other 2, we can now just plug in the values for each of these. So sine of A, we found that here, that's negative 24 over 25. Cosine of B, we found that is 4 over 5. So plug that in. And then cosine of A, let's take a look at that. We were given that is 7 over 25. So plug that in for cosine of A. And then sine of B, we are also given that one. That one is negative 3/5. Now take this and reduce it all down. Let's see, we get negative 96 over 125. See there, we get, hold on. All right, I think I've seen a mistake. Hold on, guys. Let's go back here real quick. This right here is actually supposed to be a negative 7 over 25. Because, again, we are in that quadrant 3. Cosine is also going to be negative along with sine. So, negative 7 over 25. Sorry about that mistake, but easy to fix. This is supposed to be negative here too. So this is going to turn out to be negative. Let's see, 21 over 25, 125. Now add those up and we get negative 117 over 125. And that's the value we are looking for. Okay, now let's do cosine. Cosine of a minus b. Let's plug in our values. Well, let's just go ahead and write out the difference identity on this one. So it's going to be cosine A times cosine B plus sine of A times sine of B. Now cosine of A, we know, is negative 7 over 25. Cosine of B, that is 4 over 5. And then sine of A is negative 24. Oops, not 25, 24 over 25. And then sine of B, it's negative 3/5. Now that we have all of those values combined just like we did over here to get negative 28 over 125 and 72 over 125, and that adds to 44 over 125. Okay, now let's go back to the previous page. Next, we are going to find tangent of A minus B, but since we already have sine of A minus B, cosine of A minus B, we do not necessarily need to find the tangent of A, the tangent of B, and then use the difference identity to find tangent of A minus B. What we can do in this case is, since we have this right here and this right here, tangent of A minus B is going to be equal to sine of A minus B over cosine of A minus B. So we're just using that quotient identity for tangent to help us in figuring out what the value for tangent of A minus B is equal to. Okay, so let's do that. Let's figure out, it's on the next page. Tangent of A minus B, like I said, is equal to sine of A minus B over cosine of A minus B. And we found those values to be, let's see, sine of A minus B is negative 117 over 125. And then cosine of A minus B is 44 over 25. All right, when you multiply by the reciprocal, these values are going to cancel, and we get negative 117 over 44. And we're done finding a tangent of a minus b. Now to figure out what quadrant a minus b, that angle, is in. Well, what I would say is let's look at the values for sine. Sine of a minus b, if we look back, that was negative, so less than 0. And then also, let's look on this page, tangent of a minus b was also negative. So the only quadrant in which those two values, sine and tangent, are both negative in is quadrant 4. Okay, so that's what quadrant we are in. We are in quadrant 4. And so there you go. We are done with that one. Sorry guys for this long video, but this is our last one, thank goodness. And it's one of our verifying the identities. We're going to be using our sum and difference identities to simplify our left side of our equation down to this right side of our equation. So using the tangent sum and difference identity, because this is the sum identity we're going to use and the difference identity we're going to use here. Let's go ahead and take this and start using those identities. So this portion right here is going to look like this after the identity. We're going to say tangent pi over 4 plus tangent of t all over 1 minus tangent of pi over 4 times tangent of t. And now let's use the difference identity on this portion. So plus tangent of pi over 4 minus tangent of t, then 1 plus tangent of pi over 4 times tangent of t. Now on this part, we reduce it in a way that this right here is just 1. So we're going to have 1 plus tangent of t and that's over 1 minus tangent of t. Then add that to, this is 1, then minus tangent of t all over 1 plus tangent of t. Now, if you watched my review video, this right here, we're going to reduce it in the same way that we did the cosine function or the sine function. I can't remember which one it was. We had a quiz over one of the other ones where we had 1 minus sine of t and 1 plus sine of t in the denominator. Well, we need to get a common denominator here. So multiply each expression here by the factor that it does not have. So we end up with, I'm going to come down here, 1 plus tangent over 1 plus tangent times 1 plus over 1 minus tangent. Then add that to, okay, multiply by the denominator, or the factor that this denominator doesn't have, which is 1 minus. And then on the next slide, we are going to multiply all of this out. Okay, notice that this denominator right here, when we multiply these together, we will get a common denominator, and that common denominator is going to be 1 plus tangent squared t. Okay, let's go to the next slide and figure out the rest of it. Continuing that same problem, we're going to have, when we multiply straight across for each of those expressions, we are going to have this. We're going to have 1 plus tangent squared, sorry, tangent t all squared. And then in the denominator, okay, since we have the same denominator, just put everything over that one common denominator. And at this point, I am also going to do the next step, which is multiply this out right here and also this out right here. You could have kept it in the previous form and do the steps of foiling, but here I'm going to do it my way, which is this right here. I'm going to say 1 squared, then 1 times t, tangent t times 2, which is 2 tangent t, and then tangent squared t. Now plus, do the same thing here, 1 squared, 1 times tangent times 2 minus 2 tangent t, and then negative tangent t squared is positive tangent squared t. All right, so here we have our ones will combine, and then these two terms will go to 0, and then we have 2 tangent t's, or tangent squared t's, so add those together, and this is what we get. We get 2 plus 2 tangent t squared all over 1 minus tangent squared t. Now, what we're trying to reduce this to, or simplify this to, is this right here. So 2 secant squared t. Well, we do have a common factor here, which is 2. Let's factor it out. And when we do that, on the inside of our parentheses, we get 1 plus tangent squared t. Let's go ahead and write out the denominator. And 1 plus tangent squared t, using a Pythagorean identity there, that is equal to secant squared t. So we have 2 secant squared t over 1 minus tangent squared t. And that is then that right there, showing that all of that is equal to the other side. Then our identity has been verified. And that's it. So I'm going to have some questions in both sections, 5.3, 5.4. I may reduce it for this class since last year we did these two sections separately. Probably we're going to combine all this together and as one assignment and work them all together in class. So I will see you then. Goodbye, everybody.